Hello and welcome to session 1 of unit 2. This session will introduce you to the type of radiations emitted by the nucleus of an atom. By the end of this session, you should be able to state and explain the various types of radiations emitted by the nucleus. You should also be able to explain the various characteristics of radiations. Let us begin by looking at radioactivity. Radioactivity is said to occur when an element or an atom with an unstable nuclei disintegrates into another element. In this, what we are simply doing is converting one element to another element by the emission of certain radiations. We shall be looking at these radiations shortly. Only elements with unstable nuclei known as radioactive elements are capable of undergoing natural radioactivity, while stable nuclei do not undergo radioactivity. Also, all elements having atomic number greater than 83 are radioactive and they undergo nuclear transmutation, or in other words, nuclear reactions, which differ significantly from ordinary chemical reactions. This radioactivity is very important to human life, even though it has certain backlashes, but it contributes immensely in medicine, in archaeology, in scientific researches, in the industry. Radioactivity is applied in engineering and even in agriculture. Let us look at the type of radiations that are emitted by radioactivity. The first one we shall look at is alpha particles. Alpha particles are also known as helium atoms, and they are given the symbol He as helium. They have a mass number of 4 and atomic number of 2. They are positively charged and they don't have a very great penetrative force. So when you put them in front of a piece of paper, that sheet of paper will be able to stop them from penetrating, and they can also be stopped on the skin of an individual. However, when they are ingested into humans or inhaled and they come into contact with certain sensitive parts of or organs in the human being, such as liver, the lung, and the bones, they are hazardous. They could cause cancer. One source of alpha particle is the radon gas. The radon gas is a colorless and odorless gas. They are formed from the radioactive decay of radium, which in turn is one of the products of uranium decay chain. Now, in terms of being hazardous, it is not the radon itself that is a health concern, but the radioactive product into which it decays, because the radon decays into polonium, bismuth, and lead, which are metals that are easily attracted to dust and can be transported in the air. So it is simply a vehicle by which members of uranium decay chain can enter the lungs. Outside the body, radon is not a concern, since alpha particles cannot penetrate the skin. Another radiation that we shall be considering is the beta particle, which is symbolized as a ordinary beta symbol, or beta superscript negative, or beta superscript -1, which means that they are negatively charged and they have high speed. When they come into contact with clothes, they are stopped, but they can penetrate few centimeters into whatever material they come into contact with before they can be separated or they can be stopped. They are also hazardous when they are ingested or they are inhaled and they come into contact with the sensitive lungs, sensitive organs of the human body. It is also important to know that when they come into contact with the skin or they are exposed to the skin for a period of time, they can cause damages to the skin. Let's look at the third radiation, which is the gamma particles. They are symbolized as the ordinary gamma symbol, like Y, and they are high energy photons, and they are about 105 times as energetic as visible light. So they have high penetrational power. Because they have high penetrational power, you can only stop them by water or by thick layer of lead or concrete. And of course, they are hazardous to human beings. This is a table summarizing the properties of the radiations emitted by nuclear reactions or radioactive reactions. You have the alpha particle which is symbolized as alpha, and the atomic mass is 4.0026 that's atomic mass unit, and has a charge of +2, and is identified as a helium atom. Then we have the beta particle, which is symbolized as beta and has a mass of 0.0000544 and has a charge of -1. It is identified as an electron. So electrons are very light in weight. We have the gamma rays, which are having no mass and no charge, but they are high energy electromagnetic radiations with high penetrational power. Let us look at the behavior of the radioactive radiations in the presence of electric and magnetic field. All these three radiations behave differently in an electric and magnetic field. For example, the alpha particles, which are positive in charge, are deflected to the negative plate when they come into contact with an electric field, as the diagram is showing here. The beta particles are negative in charge, so they are deflected toward the positive plate, and then the gamma rays, because they have no charge, they pass through the electric field. This deflection depends on the mass of the particles. So alpha particles are heavier, so they are deflected less as compared to beta particles. Also, in a magnetic field, the alpha particles will pass through the magnetic field because they have no charge, and the gamma particles will pass through the magnetic field because they have no charge, and the alpha and beta particles will be deflected in opposite directions. It is the behavior of these particles, especially beta particles, in the presence of magnetic field that allow our televisions in the house to work. So let's briefly look at this one. How does your television in the house work? Your television has a phosphorescent screen that is bombarded with precisely directed beta particles. If you look very closely at your TV when it is turned on, you can see small blocks of colors on it. Every second your TV shoots 60 beta particles, starts shooting it in one corner and works it through and across the screen, then it drops down to the next row. So the beta particles will move from one corner of the TV to the other corner and then drops to the next row, and it continues like that till all the screen of the television has the beta particles scattered all over it. These beta particles hit every block in every row, then begins again. It will fill the screen 60 times every second with color blocks. These blocks, in conjunction with each other, present the image that we see with the eye. Let us look at the classification of radioactivity. So there are two main classifications of radioactivity, which are the natural radioactivity and artificial radioactivity. Let's consider natural radioactivity. It involves the spontaneous emission of radiations by substances, and these radiations are emitted by unstable nuclei, which are being converted to stable nuclides. There are basically three naturally occurring radioactive series among the elements that are on the periodic table, and these series include the uranium series, actinium series, and the thorium series. Each of these series is named after the element at which the series starts, except for actinium series, which starts with a different uranium isotope. Each series also involves the decay through a number of unstable nuclei by means of alpha and beta emissions until each series ends on a different stable isotope. Let's look at the artificial radioactivity. The artificial radioactivity involves unspontaneous emission of radiations by substances. So, in this case, the artificial radioactivity method or is a method of inducing a nuclear reaction to proceed. So, in this case, the nuclear reaction is forced and it is done by bombarding a stable nuclei with certain particles. So, the first artificial transmutation was caused out by Rutherford in 1919, where he bombarded nitrogen gas with alpha particles and he managed to obtain oxygen and hydrogen. So the isotope oxygen and hydrogen are stable and there will be no further disintegration. These are self-assessment questions with the solutions, which I would want you to have a look at them.